Okay. Welcome everyone to Data Science Sydney. The Actuaries Institute, as usual, is delighted to be hosting these meetups, as data science is a key part in actuarial work, and it's also part of the Institute's strategy. We've got a strong data science community at the Institute of Actuaries. We've got a data science practice committee which tries to look into all the emerging issues and trends in data science, including ethical issues. And generally, data science and actuaries tend to work fairly closely together. And this is one of the things here is just trying to bring those communities together. And I'd like to introduce Eugene, the founder of this wonderful group, to the lectern. Thanks.
Well, thank you very much, Bill. And worth mentioning that we wouldn't be here now, Bill, because Data Science Sydney did go dormant for 3 years. And it's only by Bill's significant and persistent efforts basically twist my arm to make me restart this group here today. So thank you very much, Bill. And thank you to the Institute for continuing to support this group for as they do. Zoe, who's organising these events every time. Sometimes things are going well and you notice how well they're going. Sometimes you don't notice. You don't notice the problems. The problems don't happen because people have managed the whole thing very well. It's Zoe's job. She's done it brilliantly again. So yeah, welcome back to what is not really called Data Science Sydney anymore, is it? Now the Sydney AI plus Data Science Meetup Group. Because AI is increasingly a topic of interest. Today, certainly no exception. Today's speaker is a speaker who requires one of those intros where I don't read the sheet, which I'm sure you've read. Because yes, Stephen is different. Stephen is special. Stephen, I've known, privilege of knowing for almost 2 decades now. In fact, a few months shy of 2 decades. And what I'll say about Stephen is he has a view of reality that's at right angles to what everybody else sees, which is not to say that he doesn't see what everybody else sees as well. But he has expert. He has these unique perspectives, which are A, unique, B, very obvious to him, and C, ones that he can actually explain very, very succinctly, very rationally, very methodically. You just can see stuff, he can communicate stuff, and it's interesting and it's useful. I expect you're going to see quite a bit of that today. Now, what I'm going to present is something frankly I can't comment about too much because frankly I can't understand it. What I do know is that it is a radically different take on the topic of AI to that of just about anybody I've heard, and probably you as well. So, I should mention that Stephen has been data analytics, data science game for over 2 decades. That is a manager of a data science team. He does work in consulting, software, many other aspects of data science. It should also be interesting to note that, as well as this incredible depth of data-related knowledge and experience, he actually started his academic life with a degree in English literature, which is interesting. Well, so without further ado, over to you, Stephen.
Thanks, Eugene. Be interesting to see how many of the your intuitions about the talk bear truth. So let's find out. Thanks for having me tonight. So one of my favorite types of conversation is the one that gets efficiently and transparently to a point of meaningful disagreement. If you can get to that, then you're in a position to learn something new. But sometimes it's hard to get there for social, cultural, psychological reasons. It can be also hard to get there because you just can't define terms. And that's been my experience with AI conversations. I've had many discussions with friends and colleagues, some of who are here in the room, that haven't gotten as far as a first round debate, let alone to anyone winning or losing. And the disconnect has become, for me, a lot more profound recently with the advent of large language models. My argument is that most concepts, including the concepts of human and artificial intelligence, we're basically unable to pin down because using the language and tools we have, we can't. So conversations about them reach dead ends. And I want to unpack why I think that is. So this is a technical talk, not that kind, no maths, not the normal kind of technical talk for this meetup. It's about the technology of language. And I'm going to start in linguistics and philosophy and move through to economics towards the end. It's probably going to take about 25 to 30 minutes for me to get to the point. So bear with me. The bathrooms are on level 1 if you need to get out. Let me fire this up again, I think. Office 2016 has other ideas. I'm going to mention that year, in fact, a bit later on. Good? Okay, 3 sections. Section 1, respect your metaphors. Most of this talk is going to be about conceptual metaphors. So what are they? Here is the first overt one. Time is money. You're wasting my time. This gadget will save you hours. I don't have the time to give you. How do you spend your time these days? The flat tire cost me an hour. I've invested a lot of time in her. I don't have enough time to spare for that. You can read the rest of these 16 statements. These are all everyday statements about time that show that we conceptualize it using money. You could probably think of dozens and dozens more. They fit together without contradiction, and they illustrate conceptual coherence, both within time and between time and money. Time and money is not the first conceptual metaphor that I've used in the talk. You just haven't noticed. I'm using plain English. I'm not obviously speaking in a poetic or kind of ornamental way. That's just how our language works. All of these examples, or at least the first sort of 6 or 7 slides of examples, come from this amazing book called Metaphors We Live By. It's a 1980 book by Lakoff and Johnson. And they show in the book that our conceptual system is fundamentally metaphorical in nature. Concepts aren't standalone things. We understand and experience concepts like time in terms of others like money. Metaphors are not just a rhetorical device or a nice to have feature of language or a thing that gets used in the humanities. They're central to how we do abstraction. Because there are systematic relationships within concepts, we see this reflected in the metaphors that we use to understand concepts. They have a systematicity in the technical language. So we can see in these examples a coherent system of subcategorizations and entailments within the metaphor. Time is money, so you can spend it, budget, invest it. That also entails that time is a limited resource, so you can use it up or run out of it. And that also entails that time is a valuable commodity, so you can have it, you can lose it, you can give it to someone else. At the same time, time is not a subset of money or money of time, nor are they examples or classes of each other. We wouldn't expect a time entry in a dictionary to refer to money, nor are they synonyms. We wouldn't expect the thesaurus entry for time to point us to money. We use them to understand each other, but critically, neither one explains or subsumes or fully derives from the other. So metaphorical structure or conceptual structure is both coherent and systematic, but it isn't total. We understand time and money in terms of each other. Where they overlap, they highlight each other and meaning is created. And a statement like, we're spending time on this talk, lives in that overlap between the two and is a meaningful statement. But to state the obvious, time is not actually money. We do treat it like that in our economy in lots of ways, but that's a signal of how closely they're related. They're not actually the same thing. So the highlighting is at the same time hiding the areas of non-overlap, the ways in which time is not money. So on the left, you can't get your time back, but you can sometimes get your money back. On the right, you can put your money in the bank, but you can't do that with your time. Those two out of union statements here don't cause us non-comprehension, but if time was literally money, they would. The key point is that metaphors provide partial rather than complete understanding of concepts. And they do that by highlighting some aspects of those concepts while hiding or obscuring others. So as shorthands in the talk, okay. Time isn't really money. I'm spending too much time on each slide and it's punishing me for it. All right. So in the talk, as shorthands, I'm going to label what is here in the grey area of overlap. In this case, the time is money. I'm going to label that conceptual resonance. And that's as distinct from the proposition that time equals money, which would be conceptual equivalence, and that would also be maths. And to clarify just the intellectual attribution here, conceptual resonance is my term. It's not Lakoff and Johnson's, as is the use of Venn diagrams to represent conceptual metaphors, where the intersection is the resonant space that the metaphor is highlighting, and the non-intersecting areas here, the blue and the yellow, where the metaphor is not operating and maybe hiding things. So far, we've been zoomed in on time as money as a case study in conceptual metaphor. Let's switch from the concept of time and money to the concept of an argument. So Lakoff and Johnson show that we routinely use the concepts of journey, container, and war to understand the concept of argument. So in my introduction, I talked about not being able to reach a point of disagreement and reaching dead ends. That's argument as a journey. I said I'd unpack one of the reasons why. That's argument as a container. And that it was a barrier to anyone winning or losing a debate about AI, and that's argument as war. In most cases, in language, metaphors don't mix. So this talk could have no direction, this talk could have no substance, but we wouldn't say that the direction of this talk had no substance. At the same time, the following three things could simultaneously be true about this talk. I covered a bit of ground, journey. I mixed together ideas from different disciplines, container, and I got shot down during questions. That'd be war. So our understanding of the concept of argument comes from using multiple conceptual metaphors because no one metaphor can do the job itself. There's no unifying metaphor that we can consolidate them into. And the different metaphors at the same time are inconsistent with each other. We can't sort of mix them together willy-nilly. We notice a mixed metaphor because it seems nonsensical. But we can use all of these in parallel to make propositions that are conceptually coherent. So just to restate, argument is not conceptually equivalent to journey or container or war, but argument has conceptual resonance with all three. So the big takeaway from this first section of the talk is that metaphors are central to how we do abstraction. You can't do conceptual work without them, and they're not a flowery rhetorical device or a nice-to-have feature of language. Section 2 is English is not a programming language. So with all that linguistics as background, I want to now jump to the domain of computing. Who thinks there might be metaphors in computing? Any show of hands. Can anyone think of a computing metaphor?
There are many metaphors, like objects.
I didn't even have that one, but it's a good one. So here are 72. All of these are computing terms that pre-existed computing. So our today understanding of these terms is drawing in some part on conceptual resonance. That is, from the intersection of the two domains, in this case of computing and English, in metaphor space. So some of these metaphors have an obviousness about them. You can go down to Officeworks and buy physical files and folders, bookmarks, desktops, and clipboards. And in most cases, the computing concepts are also conscious implementations of those physical world counterparts. And as such, you'd expect them to have many properties in common. You'd also not be troubled by the conceptual limits of those particular metaphors. So, example, you know in computing that the desktop is just another file and the folder is just another file. But it wouldn't confuse you that the Officeworks versions, didn't conform to that conceptual structure. You can also see metaphorical systematicity here within computing. So at some point, via what Lakoff and Johnson call an orientational metaphor, it became the convention that servers were up and clients were down. So you upload to a server, you download from a server. And then it followed that you uploaded to the internet, downloaded from the internet. And then when we conceived of the internet as a resource, it was coherent to conceptualize it as a cloud, floating up in the sky and not taking up room in the office. So those are sort of just some systematicity inside computing. And I've bolded 4 of these terms here: communication, information, language, and memory. Because for the purposes I'm interested in, they stand out. So first of all, they're foundational concepts within computing, and they do a lot of conceptual heavy lifting within computing, and they're also conceptually interrelated within computing. And at the same time, they do conceptual lifting outside of computing, including in discussions about intelligence. And those are in contrast to terms like, mouse and cookie. which don't carry much conceptual load in either domain or generate much conceptual resonance or systematicity. But nonetheless, one takeaway from this slide is just how many of the concepts we use when we talk about computing are metaphors. I think what we'll do is close the program. And obviously, Stephen needs to be a little bit faster on each of the slides. It's okay, I'll just get it up. I'm up to slide 11.
There a memory leak?
Could be a memory leak. Okay.
Suffering from conceptual recursion.
All right.
Upload it to Google Docs.
Save the program.
Something.
Yeah.
Sorry, just
resave it.
Memory leak. How does memory leaks in humans?
Does the metaphor hold up?
Yeah, so
It doesn't have to.
We sometimes make nonsense sort of metaphors that unfold actually the original.
So I'd say
metaphor.
we talk about memory loss with humans, and we can talk about losing memory in a computer.
Yeah.
It's not clear that we talk about a
It's
leak.
not the same meaning like memory leak.
So I'd say in your sort of mental Venn diagram, a memory loss would be in the middle. It's conceptually resonant between computing and English, but a memory leak would be on one side or the other.
Very dynamic and distorted.
I think that one of the points I'll make in a minute is just the way that you extend metaphors. One of the ones that's been interesting to me recently. Want me to duplicate? All right. I'll just go like that. Yeah, cool. All right. One of the metaphors I've spent a lot of time thinking about recently is technical debt. So it was a deliberate application of a metaphor by programmers to try and explain to management how programming worked using something that everyone understands, which is mortgage debt. And the metaphor holds up surprisingly well. It's a very rich, very deep metaphor. You can sort of conceptualize changes in velocities, interest rates. There's all of this interesting stuff about technical debt. So it's an example of a really sort of good technical metaphor.
I think you may have said we need the metaphor.
Please correct me if I'm wrong, but I think you may have said we need the metaphor like a container to understand the concept of an argument. Do we need other metaphors to understand the concept of a container? Does anything have its own definition without a metaphor?
The container one pops up a lot in the book. There's hundreds of these in the book. I've only chosen a few, but the container one definitely is quite, ideas are also containers.
So there may be concepts at the bottom of the tree that are used to explain other concepts. Is that what you're saying? Do any concepts have their own root conception?
It's not clear that they do. It's clear that what you're doing when you're drawing on metaphorical overlap is getting at some shared concept, but it's not clear that you can always distill down to what is the who am I thinking of? The linguistics.
Chomsky.
Is there a sort of Chomskyan underlying primitive set of concepts? Don't know. Not clear. Right. So can we go to slide 11, which I think is just the one after that? Great. So far I've been talking about the space of overlap between concepts, and I've labelled that space conceptual resonance, and I've talked about it as though it's independent of time. You know, we use our understanding of money to understand time and vice versa, and that conceptual interrelationship has been very stable for a long time in our culture, certainly. In fact, it's only got stronger. I now want to talk about meanings that shift around over time. Computing's a really good domain for illustrating this because most of the terms are so new. And I'm going to run through 3 cases that show different kinds of semantic shift. And the reason I'm doing that is I'm interested in 2 questions. What's the path by which a concept changes its meaning over time? And then what potential for conceptual confusion does that create? Case 1 is domain-specific concepts. So on the previous slide, lots of examples of words that came into computing from outside computing. There are not so many that I can find that actually originate in computing, but here are some. Blockchain, byte, encrypt, internet, malware, metadata, software. I think what does stand out is that they're all compound words or portmanteau words. So you can kind of see the working. And I've picked those because they haven't crossed over into general English usage either. So the computing use remains the only use for these terms. So we could say that they don't project any conceptual resonance beyond computing. Another way to say that is that there are really no metaphors operating here with these concepts. And my claim is that these terms as such don't set up much potential for conceptual confusion. In other words, what you might call the philosophy question, what is metadata? What is encryption, is basically the same as the dictionary question for these concepts. Case 2 are crossover concepts with resonance. So download and reboot have crossed over from computing into mainstream usage. I might have said to David today, I missed the meeting, let's go downstairs and you can give me the download over coffee. Or I might talk about how a childhood friend and I have rebooted our friendship after a long hiatus. And the conceptual resonance here is from the virtual to the social world. And we can describe like the semantic value add, the idea of a reboot, taken from computing, very subject tonight, fresh start, things have been fixed, unwanted baggage has been wiped away. You can sort of see what's going on in the metaphor. And then the download conveys a sense of sort of fast, reliable, complete transfer of information all in one go. So these are efficient ways to communicate new shades of meaning. And prior to computing, we didn't have them. We would have had to use other words, other terms. Case number 3 are crossover concepts that erase their tracks. So here, the computing use is so dominant that it's resulted in the erasure of the pre-computing concept. So nerds know that data originally meant a collection of values and a single one was a datum, and that English usage goes back to the 17th century and there's a Latin origin and it gets consciously adopted into computing with that meaning of a kind of a set of values, observations, measurements. That's part of that. That is the conscious computing implementation of the metaphor or of the concept. But you'd also say that today in 2024, the concept of data is really entirely a computing one. We don't now conceptualize data outside of computing. And furthermore, we conceptualize computers as data processing machines. That's what they are. Now, necessarily there was a crossover period. So data wouldn't have been synonymous with computing in, say, 1960, because there would have been conceptual resonance at that point with the paper-based as well as the digital representations. But that's now history, and really only an etymologist or someone who's reading old documents would care. Algorithm is an interesting case because it's semantically shifted in the past and it's doing it again today. So there's a 17th century usage, which comes from Latin, Greek, Arabic, all three. And then that informed the computer science meaning that was standard when I learned to program, and probably when a lot of you guys learned about algorithms. It meant a precise, finite set of instructions for processing data. And since the magical year of 2016, we can observe algorithm is now becoming reconceptualized in the mainstream as this kind of opaque, nefarious business secret. Right? It's a bad thing that big tech companies do. So we're seeing the meaning shift in real time with that one. Nonetheless, when a metaphorical concept fully crosses over and then the non-overlap source space, in this case, paper-based data, when that gets erased, in effect, they do cease to be metaphors. So similar to the case one terms like blockchain and malware, which have never crossed domain, in effect, there is no conceptual resonance here. They're not really metaphors anymore, and they don't set up any conceptual confusion. So that gets us to section 3, which is to talk about conceptual confusion. Okay. So there is a template for what I think sets up conceptual confusion, and that comes from case 2, which is the crossover concepts that have resonance. Here's the essential trade-off. Metaphors are how we develop conceptual understanding. They allow us to understand more concepts and new concepts. Metaphor is the general purpose language tool that we use for abstraction and for generalization itself. So that is their upside. But there's a downside, which is that the same general purpose tool also introduces the potential for conceptual confusion whenever it is used, because the mechanism of understanding is of one thing, but by another thing, which is a different thing. And here's the template for, I think we've gone forward more than one slide. That's the one. Yep. Here's the template for conceptual confusion with milk plugged in as a harmless example concept. So as children, we probably all drank mother's milk. As kids, many of us drank cow's milk. As adults, a lot of us drink coffee. Today, there's a standard choice of white liquids that you can put in your coffee. First 3 are called soy milk, oat milk, and almond milk. Then, yes, there's also cow's milk, not mother's milk. So in the context of coffee, milk is a conceptual metaphor. However, if we generalized from that narrow context of coffee to almost any other milk context, like cooking or nutrition or means of production, we would risk confusion. Studying almond milk processing methods is not going to teach us anything about lactation, and studying mammal biology is not going to help us design better almond milk factories. Another way to say this is that the philosophy question, what is milk, is not the same as the dictionary question. The philosophy question can't actually be definitively answered. You either conclude that there are multiple milks or that milk is still something of a mystery. So let's now move from the metaphor of milk to the metaphor of computation. And I'll quote here. Information is the reigning metaphor of the moment. We tend to interpret the mysteries surrounding life in imagery suggested by the most complex system we are aware of at the time. Once nature was described as a body, then a clock in the age of clocks, then a machine in the industrial age, and now in the digital age, we apply the computational metaphor. To explain how our minds work or how evolution advances, we apply the pattern of a very large software program processing bits of information. None of these historical metaphors is wrong. They're just incomplete. Ditto for our newest metaphor of information and computation. Now, to fully appreciate this quote, the author, Kevin Kelly, means information in the Claude Shannon sense, where it has a mathematically tractable definition that relates to the mechanical transmission of bits. Information in that sense has nothing to do with understanding or with meaning. Now, I mentioned in the slide above with the 72 computing metaphors, communication and information are kind of two conceptual heavy lifters inside as well as outside computing. And one illustration of conceptual confusion is that we can see here that they have definitions that are in direct conflict. So Shannon information is a measure of uncertainty reduction, the less uncertainty, the better. In mainstream usage, information's semantic value is its surprisingness. In other words, the more uncertainty, the better. Shannon communication is a measure of lossless transmission independent of content. Interpersonal communication implies meaning and significance. It's all about content. So when we use either of those terms in the domain of conceptual resonance, which is shared by human intelligence computation, i.e. the one that we're in all the time when we talk about complex systems and the meaning of life, we are by default in a state of conceptual confusion. If not actually, then at least potentially. So this article gives a more expansive account of the history of conceptual metaphors for human intelligence, which, as you can see, does bear out the Kevin Kelly claim. To quote, the information processing metaphor of human intelligence now dominates human thinking, both on the street and in the sciences. There's virtually no form of discourse about intelligent human behaviour that proceeds without employing this metaphor, just as no form of discourse about intelligent human behaviour could proceed in certain eras and cultures without reference to a spirit or deity. The validity of the information processing metaphor in today's world is generally assumed without question. And if you read the diagram from clockwise from noon, you basically go from ancient myths and the Bible all the way through to the singularity, sort of via the industrial and computer revolutions. So one caveat on this piece is it's also quite polemical, and it falls into what I think is a trap. So Epstein, the author, states as an aspiration, quote, to begin to build the framework of a metaphor-free theory of intelligent human behaviour. I can see why that seems desirable, but I also think it's a mistake, because I think my interpretation of Lakoff and Johnson's work is showing us that actually metaphor-free theories are a fool's errand in most, if not all, cases. So quite the contrary, I think the historical swapping in and out of different metaphors for human intelligence here is an indicator of three things. First, underlying conceptual depth and richness. There's a lot of conceptual resonance there. Second, I think economic progress. Note that the transformative technologies of the Industrial Revolution and now the digital age are the dominant metaphors for human intelligence in their time. Third, I think all of this indicates conceptual potential. So in the framework I've been applying, for every zone of conceptual resonance where two concepts highlight each other, there are hidden areas on both sides. So there's a lot more potential here than what we're literally looking at when we're just focused on the overlap. So, do our brains process information, retrieve knowledge, and store memories? In that piece, the previous piece, which was written in 2016, Epstein clarifies that our brains do not literally do any of these things, although computers literally do all of them. And had he written it 7 years later, he might have added any more than a large language model literally has visual perception and therefore can hallucinate. So we nonetheless can read that top line as a coherent claim because it does live in that zone of conceptual resonance shared by human intelligence and computation. But the proposition that my brain, runs mental models is equally as metaphorical as the proposition that AI hallucinates. And that second one is a metaphor we've witnessed being adopted in, literally in the last 18 months. We've seen it happen. So let me restate my core assertions. We're almost at the end. So number one, metaphor is the general purpose language tool that we use for abstraction and generalization. Number two, whenever we use it, we create conceptual confusion if we treat resonance as equivalence. Number three, the relationship between human intelligence and computation is metaphorical. It's resonant, not equivalent. 4, computation is also our go-to metaphor for mystery, for that which we don't fully understand. And proposition 5, by its operation, the computation metaphor is hiding aspects of our own human intelligence from us. So the big back question becomes, okay then, Steve, what's it hiding? And then you can go and turn those into AI benchmarks, right? That's the game. OpenAI's mission statement defines artificial general intelligence as, quote, highly autonomous systems that outperform humans at most economically valuable work. So if we assume that a lot more useful AI is coming, to me, the central economic question is to ask, what are the human complements to AI? Because they will, in relative terms, become scarce and therefore valuable. In other words, what aspects of human intelligence are being hidden by the very salient and pervasive highlighting of its conceptual overlap with computation? This may be unsatisfying, but I've just got 4 placeholders here as places in which to look for answers. The first is physical. I think it's the most obvious. We're not made of the same physical stuff as computers and robots, so there must necessarily be tasks that we can do better than machines because we have different affordances. If we go engineering, all optimizations involve trade-offs. Human bodies have different constraints and limitations to everything non-human. So that doesn't automatically confer value in an economic sense, but it does at least set up difference. Second area is social. So it seems inevitable that one result of AI is we're going to be flooded with new information all of the time, but most of it will be fake. A lot of it's going to sound really convincing, but most of it won't be true. How do we do business in that world? How do you find needles of actionable truth when your world is an ever-expanding haystack of distracting bullshit? I think this is a really hard question. One thing that might happen in such a world is that the value of interpersonal trust and face-to-face communication just go way up because those are things that can't be faked by machines. My third domain is embodied, and this one is effectively, it's an extension of the physical point, but into the cognitive domain. I've got a really long quote here, but rather than read it, I'll just sort of make the summary point is that the substrate on which the cognition is happening or the computation is taking place really matters. So we can't expect computational equivalence between a human running on wetware and a machine running on silicon. And that, again, so that just predicts cognitive differences between humans and machine intelligences. So again, we have one of the starting conditions for economic complementarity, given that prediction. The final domain is tacit knowledge. And this one is, in effect, the extension of the social point, but into the cognitive domain. Humans possess tacit knowledge, meaning knowledge that cannot be explicated. It's only accessible to us and comprehensible to us by virtue of socialization. Socialization being the acquisition of experience, which varies from place to place and changes over time. We absorb from society far more knowledge than we can articulate or encode or transmit. By contrast, computation is a set of mechanical transformations that can only be performed on explicated information. So this one very much a talk for another day. This is the one that interests me the most. But before thinking about another talk, let's go to questions and see if we can get some meaningful disagreement going.
Thank you, Stephen, for a very interesting, brilliant talk. It's good to see this talks in AI and data science extend to philosophy and other realms beside the just the pure technical. I disagree that the use of the information processing is metaphorical in a case of humans' intelligence. And I just, in probably try to test the idea. What about DNA in biology? DNA use information processing, and when we say DNA, the cells use information processing. We're not really using, because here I know the metaphor with the intelligence works very well, but in biology, it's information processing. And I will argue the same thing in our brain. Our brain, independent of the mind and all the mental images, works on information processing from the senses and all the rest of the intelligence. So I would challenge the point about it's metaphorical.
Good. Yeah. I think the resource I'd point you to is the Epstein piece, which I've got linked in the slides. He is the one who's saying, when you look at how the brain really works, it does not store memories. It does not process information. So that's one source to go to on that. I don't know enough about biology to know at what point the metaphor breaks down, or if you like, at what point the metaphor becomes a metaphor.
Robert Steele is not a neuroscientist. Our information processing method concept comes from neuroscience, and neuroscience is actually we record things digitally when we do brain imaging and Neuralink and all this thing. It is really digital. So we are talking about information processing. We're talking about computation in a general abstract sense, not obviously in the same as the hardware of a computer.
So you agree that the language of neuroscience is very much expressed in terms of computation?
Yes, absolutely.
You're just saying, no, that's literally how it works. It's not a metaphor.
I like it, okay, because actually in our human language, we cannot get away from metaphor. So that's why I'm saying that it's really, I believe that the brain works as an information processing machine. Okay, different than the computers, but it's very using the same concept.
So we might meet in the middle. Would you agree that the way that the brain processes information is not the same as the way that a computer processes information?
Absolutely, yeah, very, very different. Yeah, absolutely. Yeah. No, I agree.
Yeah,
but it is information processing in a sense of Turing and Churchill when they talk about a computing machine. A Turing machine is an abstract machine. It can be manifested by a digital computer. It can be manifested by an animal brain.
Yeah. So my way of saying what you're saying is almond milk is actually a milk, just doesn't get there by lactation.
I give up.
That's what I think you've got it backwards. You've got it backwards. It's not that machine intelligence has been, okay, so almond milk was designed to be like milk. Machine intelligence was designed from the ground up to mimic the biological structures of human intelligence. The mathematical models computed by the machines are based on the neurobiology of humans. So in that sense, the words memory, the words that have been brought from human intelligence over to machine intelligence were done deliberately.
I made that point.
Yeah.
I said in my slide of all of the computing metaphors, most of these have been conscious implementations. The desktop, the file, the folder, and it's true also with neural nets, right? They're a conscious implementation of how we think the brain works. The point still stands. They're not the same thing.
But isn't the goal to eventually then be the same thing?
Oh, I'm not talking about the goals. So I think that we're arriving at different points of similarity and difference between the you know, what's outside, what's on the left-hand side or the right-hand side of the diagram versus what's in the middle. I don't think the goal matters.
Is this more like this is why there's disagreements in the AI spaces, because it is not fully overlapped yet, and people are unable to conceptualize, are running into conceptual confusion due to that?
I don't think the goal is relevant to whether or not there's conceptual confusion. So what gives rise to there being confusion is, are we employing a concept that is shared? And in the highlighting of all of the things that are shared, are we overlooking significant things that are in that hidden category?
Thank you very much, Steve. I'll start with something else before I make my point. When we talk about human intelligence, and these things are just metaphors for what we think is human intelligence, but the biggest metaphor is machine intelligence. So I prefer that we call, rather than artificial intelligence, augmented intelligence, because it does not have a comparison with human intelligence. We just pretend that we are trying to pretend that we understand human intelligence. We're still discovering. So I'll make the sort of main point. You just open the Pandora box. I was working on like these nuances with language, and the main reason why I promote so much Esperanto, because it's much so clear. Actually, it's about information, not about metaphors, which unfortunately do not translate culturally correctly in other languages. And the irony is actually that most of the other languages take not translation, but actually directly, literally the English word, which makes it even more nonsense, because behind that sort of literal transliteration can be different understanding, a different meaning, and we just create a bit more chaos in terms of how we communicate, how clearly we communicate, and in terms of just one example, when you say time is money metaphor, okay, in different cultures is interpreted differently. For me, time is much more than money. Time is as a concept from the dialectical materialism point of view, is not physical, and you cannot sort of give time, neither get physically, but it's a concept which helps us to abstract things and to understand better things. But money is even worse than that. It's just promise, okay? Because it's just somebody says this is a promise that your value is like equivalent to this thing. By the time you try to convert, it's totally different thing. For some, it's up. For most of it's less. So in terms of languages, it's very essential that we are actually we are creating more chaos in terms of understanding. So what we think it's like a technically value, it can create. That's why people are actually scared of the effects of AI, is because actually it will have unpredictable results in terms of how people take the thing and how it's interpreted. We can discuss later details. I think that was enough.
Yes, sorry, just to keep it quick. But Stephen, yes. So do you think? I mean, it's perhaps different angle to this, but I guess the traditional kind of dichotomy between behaviorism and I guess cognitivism or whatever. Is there anything other than observed behavior to a system, right? Or does it even matter what it is? Like inside the system, if the observed behaviors are the same. I mean, that seems to be pertinent to this discussion. And I again, if it comes to any kind of formal evaluation of any system by its nature is well, in most cases has to take an external view. But how do you think that kind of? And when you think about intelligence, maybe there is something about the structure or how the states are processed, experience of the states being processed. Again, kind of loading up on these metaphors. But how do you think that connects to to this discussion?
I think I was certainly thinking about that earlier today, in that one of the disjoints in conversations about AI is a lot of the concern is not about stuff we're actually observing. It's about extrapolations and, if you like, more conceptually based concerns. And the experience of working with systems more closely, you don't have the same. It's very clear when you're using computers, they're very, very different to the way they don't work at all like humans work, right? It's really obvious. So I think the reason I'm a bit more focused on the conceptual dimension is because that's where I sense a lot of the arguments start to really depart from each other. I don't know if I've answered your question very well there.
Thank you.
Sorry, Stephen. I think this is really a thought-provoking presentation. Really love it. I wanted to just get your view on what are the areas of resonance, the one in the shaded portion, which is causing people to think that human intelligence or machine intelligence is like human intelligence, which is what I think, a lot of people, and you're basically saying, no, they're completely different things. But I'm just trying to understand what is in that resonance space, if you can share some examples, which you think is culturally driving us to basically treat both of them as the same.
Almost all assertions about intelligence assume it's a computation process, and take as the inspiration for that the way computers do intelligence. So I've deliberately avoided the word intelligence without it being human intelligence, artificial intelligence. What I'm really saying is intelligence is a milk. There are multiple intelligences. The what is intelligence question is a mystery. It's not something we answer with words. So they're just diverging processes, diverging types of things.
Cool. Thanks. Got it. I think you've answered my question. Great. Thanks.
I always thought that maybe the use of the word intelligence for like artificial intelligence is the main reason why people have those kind of false ideas. Because actually with intelligence, like human intelligence, the use of word intelligence in human intelligence is actually non-trivial concept that we don't clearly understand. And using that word to this very unknown new technology is a very bold idea. And I was just thinking about this idea while you're talking. And just one idea is that they're using this word intelligence maybe to make this new technology more appealing, that it's actually doing really, really intelligent things. So I think like one of my assertion is that maybe we have to change the definition, rather than intelligence. Mathematically speaking, what machine learning is doing is just extracting targeted information with a high probability as much as possible.
So I want to try and unify a few different questions and responses. I think your point was that actually,
if you think about it from
it's been the inspiration, like the pursuit of intelligence in computing has been one of the guiding lights, right? It's the true north.
Yeah, like from like espionage and stuff, like intelligence is processed information. And it's like, machine intelligence is like the idea was to create that processed information in a way that seems similar to human processed information.
Yeah, I don't think that so just to respond to one thing Dimitar said, I would never say it's a mere metaphor. Section 1 is respect metaphors. They're doing a lot more work than you think. They're not to be denigrated, and any of your dictionary definitions of what a metaphor is basically says, oh, it's this sort of rhetorical thing that poets use to convince people, and you know, Plato got rid of it all, right? No, I mean metaphors are, as I say, it's a fundamental thinking tool that we have. So that they shouldn't be denigrated. I think that the reason I'm very focused on conceptual confusion is because I think when you get to comparing, to Dimitri's point, actual performance of humans versus machines on a given task, you can do that. The conceptual mistake is that you extrapolate from the performance on a comparative task that because intelligence is a coherent thing, that the machine must therefore, if it can outperform a human on this task, we assume that it has the competence to outperform the human on all the other tasks. Why? Because it's all coming from intelligence. So this is where I think the conceptual mistake starts. It's not about the specific comparison, it's about all of the extrapolation that, you know, assuming a kind of conceptual equivalence then guides you into.
Well, so the reason why I disagree with the use of intelligence is what really computer software program does is really very simple task of adding something or locating something, compounded very, very much to do a complicated task. So everyone who had a programming experience knows that how programming languages actually, computers can be actually stupid because it can't detect any mistake that I make. So in that sense, I think it's not intelligent. And that's one reason why I would say from what I hear from you, people think this collective outcome as an intelligence, but if you really think about the micro level of what computer actually does, should we really think that's intelligent? You know, it's just small computation compounded, done in a very fast computer programming processing technology. That's it.
Yeah, you're not the kind of debate partner I have trouble with. My friends are all a lot more worried than I am. They're not, you're taking a kind of quite reductive view and saying it's all very just simple. It's just, you know, things are just happening at a very large scale. I don't think that view is certainly not a universal view.
Can be friends.
All right. Stephen, my name is Sahil, and I'm confused which part to compliment you more for the thought-provoking presentation, or your braveness to take some very heavyweight and deep questions. So I'll probably simplify it. In my mind also, I was simplifying it as part of your Venn diagram right now also. The part where the two meets, I was thinking of an example, the prompt engineering skills as something which is, so it is playing like a bridge between, yes, of course, you're a human mind and maybe an AI or machine mind works differently, but it is bringing in a bridge between how humans are learning how to get the right extract out of a machine, and machines are invariably every single day learning more of how to understand what the human mind needs out of me, right? So would that be something that you think will be a bridge between the two ways how these two minds, or the machines, or human mind and the machines work? Yeah.
I guess my intuition is that humans, machines, human intelligence, artificial intelligence are much more complements than they are substitutes. And then to the extent that they are substitutes, that's just at a point in time, and humans are very, very good at inventing new things to care about. So I'm a lot less worried about people losing their jobs permanently or all in a rush than I think a lot of my debate partners are. Because I do see the sort of the complement as kind of a natural way of coexisting. That's how humans seem to use tools. Yeah, I'll stop there.
Thank you.
Keep taking questions. Plenty of-
Certainly from Jan, he's flown all the way from London to ask this question. Yeah.
And thanks for the rain. I think we'll agree on something, which is when the mainstream talks about a new technology, they masker language, right? And I think we maybe understate the fact that actually it was a year ago that we started having the debate was, is it hallucinations in AI or is it confabulation? And there actually was a pretty deep conversation about trying to refine those metaphors as we go along. And I agree with you that it is a problem when it seeps into bad thinking. You made a step, this is maybe where we might disagree, or maybe this is a path forward. I'm not sure. Maybe you can help me to understand if we are disagreeing. You made a statement, and I don't want to put words in your mouth, but the way I heard it was that we make this mistake of effectively overlaying of all forms of intelligence, right? Is basically of human intelligence we relate back to computation, to machine computation. Is that fair? Is it a fair statement of what you said just a few minutes ago?
Computation is our current metaphor for conceptualizing human intelligence.
Gotcha.
Yep.
Yeah, thanks for repeating it. So I guess he's not here to defend himself. The late Daniel Kahneman, in his book, Thinking Fast and Slow, brings out these cognition concepts, and I'm deliberately using the word cognition instead of intelligence, of type 1 and type 2 thinking, again, not using the word intelligence. And I was wondering if that is a way forward of saying, actually, yes, we can let the New York Times and mass media try, mess these metaphors up, but there actually are ways of actually trying to classify forms of cognition which aren't as reductive, as in type 1, very reactive, type 2, very analytical, and maybe closer to some machine concepts, but type 1, probably way less. So we do have distinctions, and we've had them for maybe 20 years. And I was wondering, how does that fit into your theory of it, and does that give us a way forward, or am I going down the wrong path?
I think subcategorizations are useful. Like, I think artificial intelligence compared with human intelligence is a useful subcategory. But I'm really wanting to avoid talking about intelligence without any category, because I think it's kind of a fool's errand, right? So I think if what we're talking about is being able to make further and further finer conceptual distinctions, that probably gets us to a useful place. Where might metaphors introduce confusion into that picture might be that in some sense we're trying to mix metaphors at the subcategorization level, like assuming a kind of taxonomy based on the first branch that we make that then sort of doesn't hold up in the rest of the conceptual system. But yeah, I don't think that subcategorization is a problem. I think it's probably a good thing.
I mean, I'm only realizing it when I say it now, but type 1 and type 2 is the closest thing to a metaphor-free description of cognition that I can think of. And I think we all, if we've read the book, know what it means, but we are in a metaphor-free zone. It feels like, or am I wrong?
I'll take the question on notice. I mean, I think you're in a metaphor-free zone when a concept you're using is only in the domain in which doesn't exist outside that domain, like malware. I mean, I could talk about, I've got malware in my brain, right? I could sort of try and get that meme into the culture and then I would have confused it. But while it's a domain-specific term, there's no metaphor. I mean, there's a sub-metaphor. There's it's a portmanteau word, it's come from software and that's come from hardware and blah, blah, blah. So there's metaphors under the surface to get spatial about the metaphor, but I think you're in less danger of confusion when you're just in a domain and you all understand you're in a domain, as most of us are when we're working, right? Like we share a language, cultures are always creating little subdomains, and there's less confusion in there. You've got Eugene and Tiberio. So.
Well, thanks, Stephen. Another iteration of a process we've been undergoing, isn't it?
It's a journey, man.
What were the other metaphors for an argument?
A container
and
war.
Yes.
There's a number of them. Yeah.
Question. So you got to a point in question time, which I think really deserves to be part of your presentation, which is it's the so what point. Well, what is it that you predict as opposed to what your friends predict might happen? And I think you made that clear. You said the whole AI doom scenario. You didn't talk so much about full-on Terminator level AI doom, but you talked about people's jobs going away. So if we suddenly saw an employment crisis caused by apparently the advent of AI, how apparent would that advent of AI have to be, and how severe would the employment crisis have to be, or would it be enough for you to say, maybe I'm not right about this? And I guess on that point, are there any upstream sort of simpler, smaller things that might be indications for you that your theory is not holding up? What would falsify your theory? What predictions do you have? And if they go awry, your theory will be falsified.
I am trying to avoid predictions because I'm really making an observation that says when we're in the zone of overlap and we're making and we're highlighting all the things we worry about. We worry about machines taking our jobs. Why? Because they seem to be able to do things better than we do. So that is a highlighting operation. I'm saying just by force of logic, there are a bunch of things we're not focused on when we're doing that extrapolation, whether it's a positive extrapolation, a negative extrapolation, or a kind of indifferent extrapolation in terms of consequence and valency and all the rest. I'm just saying there's got to be other things out there that are very different, that are not highlighted by the comparison points that we're making. So that's kind of, I don't know if that's a point of faith. It's just a point of observation to me, sort of conceptual observation. One of the slides I took out was, it struck me that one of the fears about AI is that it's converging on human intelligence in some sense, like it's taking over our jobs, all the things we used to do, it's now doing, right? There's sort of that kind of formulation. And I wondered whether if you took all of those types of statements and applied them to time and money, where would that get you? And, you know, are we doing more and more things with our money than we used to do with our time? Yes, we are. It's called specialization. It's called trade. And I ended up thinking the relationship between time and money is too sort of economically intertwined to make the point in a clean way. But I don't think that I see convergence. I see more like substitution happens and then complementarity happens and then you get more and more specialization. But I'm really talking about sort of what do I think is the economic prediction, not the does this put really powerful tools in the hands of bad actors prediction. I'm not saying that's not possible because of metaphor. I guess I haven't really touched that or sought to make any predictions.
Okay, I take pushback on your comment about computers operate very differently from our brains. And this comes back to this gentleman's question is computers, they just do simple functions at scale. I actually don't know the difference between that and my 85 billion neurons and trillions of synapses operating very simple functions. I think they're actually kind of the same thing. But if you look at our lineage go back to something like a spider, which also has a biological brain. If you stop, they build complex webs. But if you stop it in the middle of a web building, it can't continue. It doesn't know how to do that. Just like freezing a program, it has to go back to the beginning and go again, start from the beginning again. It can't take off where it left. So I think in that context, animal brains are quite similar to machine brains, except just that we've taken the number of connections to several orders of magnitude to the point where we can see past that. And I don't know that machine intelligence can't get to that point soon.
I think you're speaking beautifully, metaphorically. One of the things you said reminds me, it irritates me whenever I hear someone talking about how little electricity the human brain consumes because it has all of these neurons. So that to me is an obvious case, is you're applying a computing construct where it simply doesn't belong because we're not getting the same relationship. The human brain just doesn't work the same way at that level. So I find you've given examples of where I think the metaphor holds up really well, and then examples of where it doesn't, such as neuron counts, electricity load, all of these things. Just to me, that's just a way of saying they're very, very different computational substrates. And I wouldn't think the right way to resolve that is one of them's just evolved a lot more than the other. Yeah, that doesn't strike me as the explanation.
Thanks for the great talk, Stephen. Really appreciate lots of concepts here. I will confess that I'm very confused. I don't know if why, but I think I found it difficult to understand many things. So maybe my question is basic question. Is like, what is the main thesis here? I'm not sure I fully understand what you're trying to do. Maybe is there one sentence? Sorry, I know philosophy for dummies or something. One sentence summary of what you're trying to do here, because clearly I see some when I was thinking about trying to parse this, I was thinking about some part of my question was actually Eugene's question. I mean, look, is this, what can I predict from this? I mean, what falsification can I make of the theory? I mean, which evidence would make me think that you are wrong about what you're saying? But then I don't exactly know what you're saying. And it's got to do also with another comment that Dimitri made, which with regards to how much of this is about behavior, how much of this is about measurement of what AI can do versus what humans can do, or statement, a ontological statement or a metaphysical statement that different substrates cannot fundamentally manifest the same kind of intelligence, whatever that, like that assumption that you made there, which I will spend an hour debating with you about at some point. But I guess my question here is look, what is the main takeaway I should take from the talk? Yeah. Thanks.
Thank you for the provocation. I think I'm probably saying there isn't a single thing called intelligence. So humans and machines are just very different. In almost all contexts, we understand that humans and tools made by humans are very different and have a complementary relationship. But we are bewitched by the metaphor that this one type of tool that we've made is just like us, except better in every way. And what has gotten us into that comparison and extrapolation is in part a conceptual confusion arising from how we use the language.
I get that. But I do have a follow-up then, given that answer. So let's say then that you give me a definition of intelligence. We all will disagree on which definition, but you give me one definition. And then I build a system that will, under that definition, outperform human. Then, okay, then you're unhappy. Then you come up with a different definition. Then I build another system that goes there and hits you on that definition. And then ad infinitum. Okay. Where do you see that dynamics taking us? Because that's the history of computing, right? The history of computing is, AI is what machines can't yet do, but humans can. Okay, so what in your theory is sort of, how is your theory connected with this, observation?
I think you've described what I would describe as the economy. And the bit I'm reacting negatively to is that there's somehow something really different now. This time is different. Machines in the industrial era, yes, took jobs, and life was bad for lots of reasons, for lots of people as that process unfolded. But on the aggregate given time, we're in a better place. So I tend to extrapolate more positively. I certainly would extrapolate increasing specialization and trade, leading to more and more complementarity and more tool use. And I would certainly say, yes, part of how the economy moves forward is people invent machines to do things that people used to do. My concern is that I think that the too much of the doomsday extrapolation comes from an assumption that there is a coherent singular thing called intelligence, and therefore the machine is somehow converging on it, and the human is under a new kind of threat. And I don't think that's the case.
Following from Tiberio's question, there is this theoretical question of what happens if we have millions and millions of questions. So we're going to cut it to 2 more. So I'm going to be very arbitrarily selective. It's not a reflection on your intelligence. I think David's hand went up.
Thank you. Let's just agree that we're terrible in terms of the way we use words. We use them loosely and sloppily. That's absolutely the case. Speaking as someone who is a pedantic, I'm especially sensitive to that usage of words. By the way, the other term or meaning of argument, it's the collective noun for a group of architects. Obviously not enough architects in the room to appreciate that one. So here's the question, or here's the challenge, rather. Given that that is what we do with language, I'd like you to invalidate the application of the Turing test. So if it looks like a duck and walks like a duck, why can't we call it a duck? Because that's what we do.
I thought that GPT, whatever, 3 or 3.5 or 4 had killed the Turing test. To me, the Turing test has just disappeared now. No one cares about it anymore.
That's my point.
And I think that's good. It just shows it was a dumb test. I don't think it was. I think it was taken too literally anyway. Like, I don't think Turing meant it that way. I think Seale's Chinese room thought experiment is the one that now gets a lot more play, because it's like, isn't the LLM just a giant lookup table? And so my problem isn't saying, is that not a useful, way of conceiving what a program might do? My problem is saying, well, that's just all humans are, is, we're just lookup tables. We just predict the next token. That's all we are. It's like,
no, sorry.
Anyway, but I'm not answering your question.
It's the observation of the behavior through which we ascribe a noun or a verb. We ascribe a word based on the observation. So unless you can invalidate, and so that's what I'm asking you to invalidate, that the observation of a behavior is insufficient to be able to ascribe a particular term definition. And that's essentially what Turing was getting at.
I don't know if I agree that we're sloppy with words. I mean, I don't think I'm saying that we're sloppy with concepts. I think I'm saying sloppy. Concepts are just fuzzy. That's what they are. And maybe words are fuzzy also. Words are definitely fuzzy.
Is this for you a feature or a limitation of our humans? Like using metaphors? It's a limitation or it's a...
Oh, it's a feature.
You see it as a feature?
Yeah. If an LLM came up with a new metaphor, I'd be impressed.
Okay, I'll allow one more question, unless Stephen really wants lots more questions. I'll allow one more question, and I'll allow it from someone who hasn't asked a question before, and I'm particularly going to be biased towards people who are asking real questions and not making statements. If you've got statements to make, maybe you want to do a Sydney AI and data science presentation on your idea. You'll have more time. You know who I'm talking about. Right.
So tacit knowledge. So from what I understand, tacit knowledge is intuition. That's what human intelligence would have, say, intuition or something that cannot be passed, right? Is that why you differentiate human intelligence and machine intelligence as a different intelligence, and we will never come to a point where there will be a complete overlap?
There are types of tacit knowledge that are able to be eventually explicated, like kind of just given enough computing power or given enough writing stuff down. There is a type that can't, and that's the type I'm interested in.
So say certain decisions that are made that will require a certain EQ or
yeah, I haven't thought about what are some other words I could use to describe things that humans do that aren't the things that computers obviously do. But I feel like that's where your question is going. I've tried to look for placeholders that, for me, give different entry points. Because I find one way in which people are a bit sloppy with language is just saying, well, humans are like creative. You know, machines aren't creative, humans are creative. And then Tiberio will say, well, please define what you mean by creative. And then we'll get into the game of finding, oh, actually, it turns out, you know, diffusion models are really good at that. So yeah, I'm trying to get into this, what's in the zone of non-overlap by trying not to hand wave and throw words around that just sort of beg the question. Yeah.
All right, we're going to cut questions to Stephen in this format short, but we're going to have an extra long networking time because we only had the one speaker. So there'll be plenty of opportunity to ask more questions of Stephen if he hangs around. I hope he does. Before we break up, please join me in thanking Stephen for a very thought-provoking. I now have a question for you, which is, well, as we all saw, myself included, this is very much a work in progress, not just in terms of what Stephen is doing, but in terms of us forming views or arguments. How many of you would be interested in an ongoing debate where we have a few more iterations of this? Maybe something from Tiberio, maybe something from Dimitri, maybe something from a few other people with a point of view, and maybe Stephen in reply. How many, show of hands for people who'd like to see an ongoing debate? Interesting. Okay, we might just do that. Well, this brings us to the end of the formal part with a very long networking session at the end. Does anybody have any announcements, particularly of a job type? Anybody? I know one of you is actually a recruiter, and you should get out. Come on, Chris. You know you want.
Can jump up quickly, yeah.
What your fingers, mate?
Embarrassing slip. But yes, I work in recruitment with a group called SKL. It's mainly across the insurance space. Started up on the actuarial side, so the majority of our roles are across data as a whole, not specifically just data science. So yeah, if you need any kind of general advice, kind of tips on recruitment and kind of access to companies, just let me know. I'm more than happy to spend the time. So,
Thanks. Hi, my name is Arun Prasad. I run a small firm in the AI space called AI Whisper. So yeah, we are definitely on the recruitment side. We're looking for engineers, especially engineers who are into fine-tuning of large language models. If you've done any work on Mistral 7B or specific professional domains, like we've done work on cybersecurity, we've done a lot of work in that space. But yeah, if someone has any real fine-tuning, if you've done like even built your own LLM models from scratch, I know it's expensive, but if you've done like Pi kind of models, or if you've done fine-tuning on Mistral 7B, Llama 2, would love to talk to you and see where it can go. Thanks.
Anyone else?
I'll try. Well, I'm not a recruiter. I did a couple of companies in the past. I'm an engineer. And lately I've been playing with AI and these things like 6 months. And I built a small toy that you can talk to it and it responds back and these things. And it's been applied to, it costs $20 to make, connects to the servers and everything. And I guess I'm recruiting more or less because I'm trying to find partners that, because I'm a technical guy, trying to find partners that could like to explore where this could be applied. For example, I'm doing some tests with a clinic that they do therapy for autistic kids. And I prepared different activities that the autistic kids can do, and these things are working good. But I've been a CEO in the past, not my thing. So I'm recruiting. We could say I'm recruiting. Yep. Thanks.
Thank you. This has been a very lively announcement session so far. Maybe the market's picking up. Anybody else got any announcements? Okay, well, maybe it's my turn. So hi, my name is Eugene, and I run this questionable little AI and data science meetup group you might have heard of. Actually, this isn't about the meetup group, but if anybody here is in the online marketing, particularly SEO space, and is interested in doing some commission-based lead generation / sales for an AI-based SEO product, come and talk to me. Other than that, thank you all for coming. You've been a great audience. You usually are. And on to the networking. Thank you.